Hey, today we're going to do logarithms. So what is a logarithm? Well, that is the function that will undo an exponential. Just like addition undoes subtraction, multiplication undoes division, logarithms will undo exponentials. So what's a logarithm? It will undo an exponential function. Here's the chant I want you to say and remember. A log is an exponent. A log is an exponent. So we would read this as log base 2 of 8 equals some number. A log is means equals, an exponent. So this says, if I take 2, what exponent do I have to raise it to that I would get 8? 2 to the what power equals 8? That would be 3. So log base 2 of 8 equals 3. These are equivalent equations. This is the logarithmic version, and here is the exponential version. So by definition, this is read log base b of x equals y. Its exponential form is b to the y power equals x. This is definition of logs. This is how you go back and forth between the two forms. Informally, I generally say drop and swap. So what is it that we drop? If you read this log base b, so b has to be the base. So the base is what I'm dropping, and then what are you swapping? The x and the y. The y comes over here to the exponent position, and then this x goes to the other side of the equal sign because the log is the exponent. Let's try another one. Log base 10 of 1/100th equals what? So if the log is the exponent, or we drop and swap, I have 10 raised to what power equals 1/100th. So if I'm getting a fraction, that means that it would have to be a negative number. And if I know that 10 squared equals 100, so that would be -2. Log base 2 of -3 equals what? So if I rewrite it in exponential form, you drop and swap. 2 to the what power equals -3. Well, let's see. If I raised it to a negative number like -2, then that would give me a fraction. And if I raise it to a positive number like 3, that would give me 8. That would give me a positive number. There's no way that I can raise 2 to any power and get -3. So this one is not possible. You cannot take the log of a negative number. You cannot take the log of a negative number. Let's start with exponential form and put it back into log form. So maybe you would go over here and use your definition of logs. So this 4 is your b, if I label that. That 1/2, that's your y, and then that 2 is your x. And so if you look back, to put it in log form, it has to go log base b. So I would have log base 4. This base is a subscript. That is supposed to be smaller and down from the log. Log base 2 equals y, that I labeled the 1/2, because the log is the exponent. So if a problem says take an exponential and write it in log form, that's what I would do. If it says take a log and write it in exponential form, that's what I would do. The second part is that we're going to have to evaluate a log. If you notice the numbers that I'm putting up here, they correspond to the notes that I am posting. We have to evaluate log base 8 of 32 equals what number? So the log is the exponent. So that means I have to take 8 raised to some power. So this is the one time you can fudge in and equals y. 8 to the y equals 32. So if you have to evaluate a log, the first thing I would do is I would put it in exponential form. Now we're going to use skills from the last section. If your bases are equal, then your exponents are equal. So I need to write 8 and 32 using the same base. 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, and 2 to the fifth is 32. So 2 is going to be the base that I use in this problem. 8 is going to be replaced by 2 to the third, and 32 is going to be replaced by 2 to the fifth. I have an exponent to an exponent, so I'm going to multiply. If your bases are equal, then your exponents are equal. 3y equals 5. Divide both sides by 3. And y equals 5/3. And finally, one with fractions. This is 16 on the notes. Log base 64 of 1 over 32 equals y. So the first thing I would do is I would rewrite this in exponential form. So we're going to drop and swap. The 64 is my base, so that's what I'm going to drop. Raised to the y power equals 1 over 32. So we did some problems like this in the last section. It looks to me like if I keep going over here with 2 to the 6 equals 64. It looks like I'm going to use a base of 2 again. First thing I'm going to do is I'm going to fix my fraction with negative exponents. 64 to the y equals 32 to the negative 1. Take your 64 and replace that with 2 to the 6th power. Replace 32 with 2 to the 5th power. I have an exponent raised to an exponent, so I'm going to multiply. So 2 to the 6y equals 2 to the negative 5. Base is equal, then your exponents are equal. 6y equals negative 5. Divide both sides by 6. And y equals negative 5/6. Hope this helps. See you next class.